Hello there, and welcome to this webinar on how to program and use Fusion for CNC uses of how to use this, the PCB place in Fusion and then CNC it on your own little mill. So this has a lot of different approaches to it, and it's quite smart that you can actually all in one software develop your schematics, do your PCB layout, have a 3D model, and also be able to CNC mill it all in one. So this is the small PCB that we're going to do today. It's one of my previous projects. It's a little old now, but I'll go over this and we'll figure out how to do like a single-sided PCB like this one. So just to tell you a little bit about what it is, it's basically just 5 switches. There has these resistors onto it, like a voltage divider, and when you then short one of the switches, it'll be a specific voltage level, and that can be sensed by this AT-tiny on the ADC converter. And then we have some pin headers for power. We also have, so actually this is the power connector, and then we have power to a small, actually I don't remember what this connector is for. Oh yeah, no, it's for a NeoPixel ring that I used. So it has a data out here and power for it. And the last thing that we have down here is we have a small vibrating motor. So again, a small pinout for that and a small little transistor down here for driving it. So I just built this all in Fusion here, and then I switched to the PCB document over here and did all my traces and everything. And I made sure that everything was on the bottom layer. Like you can do both top and bottom. If you want to do it on your CNC, you can just flip it if you want to, but it's a little bit more complicated and needs a little bit more of alignment. But it's totally perfect to do in Fusion as well. But you can only do like 2 sides otherwise. If you want to do like 4-layer boards, you have to get them ordered from China. That's cheap, but if we want to prototype or make our prototypes a bit more, a bit better quality, I think that PCB milling is the way to go. It's a really important way of working. So let's just jump right in. So I exported it over. I can just show you how I do that. So I make sure to export over to a 3D for a 3D design PCB. So if I click on this button here, then it'll jump over to the design. So here it is. The switches are not really in a 3D package yet, so the Fusion just models them like this. I can just see a little bit on my screen that it might be like it might blink out sometimes. I don't know if you guys see the same thing. Please let me know in the comments if I need to fix something like that. So I am on my computer alone today, but I do have the chat open next to me here. So if you see me looking over, I will. That's the reason why I'm checking just if something is happening. So here on the bottom layer, we have all the tracks, and some of the things that is really important when you want to PCB mill something is the clearance that there is between the ground plane and the traces. So the spacing in between here for the track and the ground plane, of course, has to be the width of the infill that you're using. So we usually use these kind of pointy engraving bits, and they have a flat area of about 0.2 or 0.1 millimeter flat. So that's really good for these kind of SMD components if you really want to get in there and make sure that it cuts out these thermal pad connections for grounding. And the clearance from this actually comes from the 2D workspace. So if we want to change that, we have to change it in DRC. So it's a little bit going back and forward in your design for 3D and 2D. So the place that you would make sure that something like this fits is you want to go under Rules, DRC, click on DRC, and then you have to make sure that you have the clearance set all right. So I've put my clearances in here, and sometimes they come in mils. I think I can load the default. I don't know if I can. I of course already did this once. I don't have a default rule check, but under clearance, it usually comes in mils, but you can change in between. So you can do mil and millimeters. It will just convert it. So that's no problem. So I'm just going to use 0.21 millimeters just to give a little bit of space in between. So I'm going to use this kind of engraving bit with a 0.2 millimeter flat on the end. So just type all that into all these fields here. The drawing over on the left side is quite self-explanatory. So just make sure that those are selected. And the same thing I usually do for the edge of the board and to the traces. And then we have under supply, if you want to do the same thing for thermal insulation, if you want thermal insulation, you should type it in here as well. And just because we're in the DIC, I'm just going to go over the layers as well. So the layers are the thing there is defining how thick the copper layer on the top and bottom and the whole thickness of the board is. So I'm actually going to change this just because I already did cut this on a CNC and I figured out that I need to go a little bit deeper for the copper layers. So I'm just going to change this to 0.2 and I have my total board thickness. It's usually 1.6. So I'm just going to subtract here so that I get the correct thickness. So that's make sure, and that's also going to set how deep your engraving bit is you're going to go. So so when all that is done, I'm going to do apply and select, and that changed all of that. So now I'm just going to push that over to 3D design as well. There we go. You can see down here in the bottom right that it will have to recompute the whole model. So it takes a second. Okay. So now that I have everything done, I can just check up that my clearances are correct. So if I zoom in and I do I for inspect, I can, or measure, then I can click on one of these lines here. This edge. Just a quick tip, if you hover and hold, you get the selection bar here, so you can select better. So you see indeed it is 0.21 millimeters, just like we want it to be. Okay, let's get ready for milling then. So the first thing that I want to do is I want to clean it up. I don't want all of these parts to be on my design here when I'm looking at it. So I'm going to turn off the packages. That turns off all the components. And then I have layer number one. That'll be the top layer down here, copper layer. I can turn that off because I don't I'm not going to do this as a two-sided design, two-part design. The next thing that I want to turn off can also be layer one here. Layer 16 is the bottom one. Solder mask. Turn it off as well. And so it does this. So you see now that it actually is bodies. So down here I have the board, and then I have my track with the copper layer, And then all the way on the top here, I actually also have a silk screen, I think it is. So I can just, if I click on one of them and I do V, they'll hide it. So it's inside of this component right here. One of the bodies is now hidden, this one. So I want it to look like this. I want it to be one single height and the copper layers that I need to cut out. Then I'm going to do the drop down over here and go into manufacture. So my setup here is already done because I did it once. I'm going to show you how to do it, but let's just first have a look at what we're going to end up with. So I get these warnings for out of date because I updated the DRC. So I can just hit on setup and do Command G for regenerate. And that's going to regenerate all the tool passes here. And it is a 3D toolpath, so it is going to look at the model and calculate the correct route. That also means that it takes a bit more computing power for them to load. So this might take a while, like I think a minute or so, and especially when my computer is under heavy load from also streaming this live. There we go. So if I just do a quick simulation of this so we can see what's going on. I click on the simulate up here. I'm going to turn on stock and I'm going to turn off the model. So this basically represents the copper sheet that you're going to put inside your machine. And I'm also going to not do the holder just because that's quite big. So it will start out doing all the traces and just on the top layer with the engraving bit. And when it's done with that, we have to change the tool to a flat end mill, and I'm going to use a 0.8 millimeter end mill for the job. So that's of course what it's going to do next. So the next operation is going to be drilling out all the holes, and the last operation is going to cut out the outline of the board so I actually have a board. So I can speed this up so it goes a little quicker. You can see that it goes through and does all the job and the whole job. And right here, you can see that it's going to change operation into the end mill. It's going to go in and cut out all the holes. Just going to skip operation so it goes a little quicker. And the last thing you will see it do is that it walks around the perimeter and does this in a single cut. Okay, so how did I do it? Let's do a new setup. So turn on the model, new setup, click on this button right here. Okay, first thing is to select your model. So under model here, you should, if it's already pre-selected something, make sure to hit the cross and make sure that it doesn't have anything selected, because otherwise it might have packages included in the models and we don't want it to have that. So we're going to hit on the bottom layer here, and then I'm going to grab all the masks, and it should be like 3 clicks or so, just so I have everything selected now, I see. Next thing is to orientate the coordinate system to the correct point and set the starting position. So first of all, I'm going to orientate it so it's right. I have C downwards right now. I can simply flip that by hitting the small arrow here. If I click on that, I'll flip it. And this orientation is actually already correct. But let's say it's not, just so I show you, just to make sure that I show you how to do it like correctly all the time. Let's say that C was pointing in like a wrong direction. So I'm just going to, so it's here, like C is in the wrong direction. So I have to make sure that that's corrected. So under orientation, it's pre-selects model orientation. You can choose another one. So you can choose like C and X axes. So that's what I'm going to choose. I'm going to choose the Z axis. Here I can choose either an edge that is parallel to the z-axis, or I can choose a face that is normal to. I'm just going to choose the top face here. So you see now I flipped it down. I can do flip z-axis. That's the same thing as hitting the arrow. And then I want to make sure that my x-axis doesn't really matter. It's round. So I can just choose maybe to be this one, parallel to that axis. And you can see that it switched. And then I want my starting position to be here on top. So I can do stock point. It's going to give me points on the stock all the way around. So I can choose the middle or somewhere else, but I'm going to choose this corner up here. And it's rather important that you choose the top point if that's what you're gonna, often we go in and we touch off on the surface. So make sure that you set your C0, your coordinate system 0 point there. Next thing is stock. I am going to choose relative sized stock, so relative size box, and then I'm going to choose the offset mode to be no additional stock. So it tells me that the height of this is 1.4 millimeters, and this is the size that I need to do the job. So it's 1.4 because we, of course, deselected the copper on the bottom. I said that PCBs are 1.6, but we also put copper on the bottom, being the last 2 millimeters, this last 0.2 millimeters. So this is fine. It's we're going to go through with like 0.5 mil anyway. So I'm just going to do OK, and that's the setup done. So now I have to program in the toolpaths. So how I'm going to do that, I'm going to choose contour on the 3D workspace, because then I don't have to select what I want to do. I just do the outline and it will do the calculation automatically on what to do. This is why I like Fusion over other programs like CopperCam and these kind of softwares, because like I'm in control. If something doesn't want it, like I programmed it, like I have the possibilities to change that. We'll just give it some loading time. Here we go. First thing should be to select the tool. So under tools here, we should select the tool. And I already did this. So I have, of course, the tools built in. I have them right here. But I'm just going to show you how maybe to do a tool like this. Loading. So can I do? Now I can't create a tool before, like inside the selection. So I'm going to choose my tool first of all, and click select. And then we will, I'll show you how to create the tools after I've done the contours, after I've done this toolpath here. So in case you want to know, like, these are my parameters. Maybe this should also be actually 24,000 RPM. So the cut feed rate that I like to use, this one here, is probably the one that people are looking for. 200 millimeters a minute is what I'm using. And I've also seen that Fusion right now has a bit of problems with the like really small millimeter values. I'm not gonna deal with that. Like I think it's some kind of a bug in Fusion. So that's just how it is for now. Next thing is contours. Geometry, and then I can do selection, and then I can select the outside of the board. So that's going to tell Fusion you can work on anything that is inside this green profile. And then I don't want it to cut out this small part right here. So I'm just going to do an additional offset for the sides. And I'm going to choose that to be -0.5, I think is going to be okay. We can always check and go back and see if it creates any problems. And then I'm just going to go over heights. I don't think I have to change anything here. Step down is also fine, 1 millimeter. Linking. Here I want to change this to be plunge, and I don't want it to have lead in and lead outs. I'm just going to leave it like those. So let's hit OK. And it just tells me that my tool diameter is greater than the tolerance that I told it to be. We're gonna hit OK for now. Like, this was not a problem a few months ago when I did this, but when I try to do a 0.2 millimeter tool now, Fusion rounds it down to almost 0. I hope they'll fix that soon. So, calculating the toolpath. I know that it's going to do one mistake here, and I can tell you a little bit about it while we're loading the toolpath, and it's because the holes, of course. So it's going to try with the tool to drill out the holes. We don't want it to do that. We don't need it to drill out every single of these holes at as deep as it can go. We're going to come in with another tool later on, and that's going to drill it out. So, but just for showing what actually is going to do, we should just do it like this. Is what I'm going to do. Okay, I think I've gotten there. So just open the setup. Usually don't find my computer slow, but if you're doing a live stream, that's heavier than you think. I found out. So you see here, the blue part is the bottom of the toolpath. So it's trying to drill out this hole here. We don't want it to do that. So my fix for it is that you can just set the height to be different. So I'm just going to edit the toolpath, and we're going to set the bottom height to be equal to like the lower layer in here. So any minute now. There we go. So under height, I can do bottom height, and then I can do selection. And I can choose this phase right here. So even if I go back into the PCB working space here, it's going to obey that this is the lower part that you can go. You also have the opportunity to do an additional offset if you figure out that you have to go deeper. It's a matter of preference if you want to change it in DRC, push it over and then fix it. And then you like fixed it for good, or you can like do the cheat hacky way and just do offset. So if I do OK now, still going to give me the same warning. That's fine. So now it is still going to like engrave the center of all of this. It's maybe not the best strategy to do, but I think it's so quick for the machine to do that that I'm not gonna bother with fixing it. Otherwise, you have to select all the holes in when you selected like the green circle here, you can select all the holes, and that will like tell Fusion to stay out of those areas. So if you have a enclosed area inside another enclosed area, it assumes that that's a no-go zone, and it will not try to do anything in that area. So, but that's just I wouldn't do something like that. I'll just let the machine run a little bit longer. Okay, so finish calculating. There we go. And if we look inside one of the holes, you see that it doesn't anymore have the cutout. Okay. So quickly, the tool, if I want to create a new tool, I can click on the tool library up here. That will allow me to create a new tool. So I'm just going to load, and here we go. So select the library, it says. Let's just do, let's just choose this document and then click add new tool. So here you can choose either between a tapered mill, that's what I'm going to do, or some people like either to do that or a chamfer mill. Chamfer mills are not that great for it because I think contours are not allowed with chamfer mills. So just choose tapered mills, and then you can go under the cutting. So we're gonna have a single flute, and it's going to be a ball nose, and the diameter of the ball nose down there is going to be 0.1 or 0.2 millimeters. Shaft diameter is usually around 3. Overall length, I'm not going to touch it. Doesn't really matter for me. You have to be specific for your tool. 50. I know it's a bit long, but I'm going to leave it. You get the hang of it. And the last part here is maybe corner radiuses down here. I choose those to be. You should choose them to be 0. But Fusion has a problem, so I'm just going to do it like point by point, like that. So I think maybe a little. I did it. And the taper angle, the ones that we are using usually is 30 degree. So, but just be aware with the angle here that it is measured for vertical. So it is going to be 15 degrees instead. And I think how I fixed that it doesn't have this huge hangout like this for my tool is I did the math. So it's just you know the angle, you know how thick the tool should be in the end, figure out how long that should be. Let's just try doing something else like 10. See. Why didn't it do that? Shoulder length must be larger than flute length. Okay, flute length. There we go. 10. 8. So you see how I'm going, where I'm going with this. So, and then I highly recommend to do cutting data. So I did a cutting data in here where I chose it to be like trace cut, and then I typed in the parameters that you had before. If you want to know them, scroll back in the video. Scroll back in the video, and you'll find it. And if we want to change the cutter to, you can change the cutter here for being, instead of tapered, you can choose like a flat end mill and go through the parameters again. Same deal for our 0.8 millimeter end mill instead for cutting out. So that's the one we're going to use now. Okay, so that's next. Holes. When we want to do the holes, I am going to do contours again. This video is going to be mostly you looking at me waiting for something to load. So first thing is the tool that I should change. So I'm just going to choose the 0.8 millimeter tool that I have. Here we go. And under my cutting data, I made sure that I had a PCB full cut. So that's the feet and speeds for, we figured out some feet and speeds for a full depth of cut with these ends mills. But of course, if you do like your whole job with a 0.8 millimeter, you can run a lot faster on the copper layer. So have a faster feed rate for that is my recommendation. So I'm just going to choose select. If you're wondering what the feed rates are, here they go, here they are. And now that I actually see that this is 150 millimeters a minute, I think you can go a lot quicker with the engraving bit, but that's on your own shoulders to do so. Geometry, I can just click on the edge. It's going to pre-select it to be selection. It knows that's what I mean. Heights, bottom height. I want this to be negative 0.5 millimeters, just to make sure that I drill all the way through the bottom and make sure that, so we have wood underneath this usually, no big deal cutting through that. So that's what I'm going to do. And then the maximum step down. This is already 1.4 millimeter board, or 1.6 in real life actually. And then we just added in an additional 0.5 millimeters. So if I want to be exact about it, I could do like 1.4 plus 0.5, and that should do it. That should make sure that I can go through and do this in one cut. Linking, again, I'm going to turn off helix into a plunge, and I'm going to turn off my lead in and lead outs. You will quite likely get errors if you have lead ins and lead outs turned on, because it's just such a tiny hole where it has to go in and do a job. So just choose OK, and let's see what kind of toolpath that gives us. As in our previous live stream, we should think about getting elevated music. Okay, it's doing something, I think. It's actually quite funny how it keeps this copper layer here. It's a low graphical error. So let's see. Sometimes we'll try to go inside the traces here and actually cut that out, but we already did that with the engraving bit, so no need to do it. I found that it didn't do it on my previous go, but I think with this long a calculation time, something's up. You just feel it. Yeah. So it is going to go through the holes. If I go under the bottom here, we can see that. So there's also another mistake here. So you see how it helixes in and actually does this kind of spiral. That's the step down set for a wrong value. And it also has the problem right now of trying to cut out these things in here we already did with the engraving bit. So edit, and we're going to fix that. So fixing this is going to be almost the same procedure as we did with the bottom height for the engraving bit. We're just going to choose now that it can only start doing work at the same face, being this one. So it doesn't look at the geometry that the tracks actually are at. We're just going to ignore those when we get the option to actually do it. Here we go. So top height, do selection. There we go. Selection to this reference, this plane right here. And just going to set this to like 2. We'll see if that doesn't fix it. Otherwise, try like 8 or 5 or something. Then that should do it. Sometimes if you're like right on the border, it'll do a step down, where we'll go in and spiral instead like that for clearing out chips. But we've done this 1,000 times before, maybe not 1,000, 100 times before at FabLab, and you can do this in one operation. So no need to do step downs here. At least that's our experience. Here we go. So you see a lot faster compute time for for figuring out the contours there. But obviously not quite finished yet. We're thinking. Interesting. Finish the toolpath, but the computer is still loading. Might crash. Does that sometimes, like the new electrical environment that they placed inside of Fusion has caused a little bit of hiccups. I think usually find that it sometimes might crash going from PCB design into like 3D design or do bigger computes like this. But I think really, like, even though that there is some hiccups, it's totally worth it. Some of the new packaging and everything they've done with the design is super cool. So here we are. Here it calculated the way that it's going to go over and do all the holes. And if I zoom in on the bottom, what we should see is one blue line going around doing like a small contour, just because the tool is smaller than the actual hole that it's going to go over and drill out. So this is quite neat. Last step is to do the board outline, and I'm going to use 2D contours for doing this, just because I find it easiest. And it's what we call a dumb toolpath. So it is going. You have to select exactly where it should go. So before we select something where like it should look inside and figure out how to cut it. But with 2D geometry, I can tell it to cut anywhere, and it will just go straight through my board if I tell it to. So so that's one thing to be aware of in 2D. So it pre-selects the previous tool used. That's also what I want. I don't want to change tools, so that's perfect. And I'm going to go under geometry. And here it's important that I select the bottom contour. The reason why it's important, you can also see that it's now is a blue color, is when I go under heights, you can see here the bottom height is selected to selected contours. So if I selected the top, it wouldn't go all the way through the board. And I've set my default to go negative 0.1 millimeters just because we do so much plywood work on this kind of CNC. I'm going to go with 0.5 instead. But most Fusion users will have this to set to 0 as the default. And then I'm going to make sure that so multiple depths is turned on. It says 6 millimeters. It doesn't matter because our board is thinner than 6 millimeters. I'm going to turn it off. Most people don't have this turned on. It's tool library specific if it's turned on or not. I just programmed mine so that it is turned on. It's a good little safety feature. I can have lead-in. I can have lead-ins if I want to. I don't like lead-ins actually. I don't find them very useful most of the time. So just turn them off. They do have their right. Some places they are quite neat, but not for this kind of job. I don't think they're necessary. So just do OK, and those usually load completely, like really fast, because it's just a line. You tell it to go on that line, it will go on that line. But the computer is a little slow here. This should be like a 25-minute work webinar if I had a faster computer. There we go. So just click on it. You can visualize and see that it actually is those 0.5 millimeters below where I clicked. So now we are at the same level again, and we can go to simulate. You've already seen this, so just quickly, but it's just a good representation of what's going on. Turning off model, and it is going to cut everything through here and do all the job. Okay, so rather cool, I think. So now that I've done this, maybe a cool little procedure would be to save this. Like 99% of all my PCBs are going to be exactly programmed like this. So I can save this as a template. I can click store on template, store as template, and I can then select this to be maybe PCB milling engraver bit. It's going to be a little different, of course, if you were going to have done this whole thing with a 0.8 millimeter tool, which we do a lot because it's just quicker not changing tools. But now if I right click on setup, I have the option to create from template, and here I can actually just click this, and it will give me all the tool paths that I just did, and save all those like negative 0.5s and offsets that I did. But when I do this, I still have to go through them individually and select where it should work inside. But next time I do this, it could be a lot quicker just having the template to do most of the work for me. So you see there, they came still arrows because there's no toolpath on them. So that's almost it. And of course, one of the things here that is really amazing in Fusion is now if I go in here and I found out that I need to have a change in the model somehow. So let's just do some minor changes to this. So if I do like move, and I move this one out here, and I found out that this right in here is a little too close, I could just move it. See what else we can do. We can flip a resistor to be here instead. So a lot of arrows right now because I of course just had problems with the traces. So just do like this, and manual route. there. Small mistake. Okay, then I should calculate my polygons, do ras nest. Oops, that was not the button that I wanted to hit. This one for polygons. It's going to recalculate all of that. Going to do view in 3D design. That's going to push it over, and no need for doing all your toolpaths again. Just like magic, we have to regenerate them, but just like so, that will be a done job. No exporting to Gerber and importing and figuring out how all of that is done. This is going to recalculate here in the left corner. Let's see if I did a change. I don't know where I did change exactly. Where? Let's see. This resistor here is that one. That should be vertical. Let's just check if that's true. Wow. Computer is, I think it knows it's dinner time. So it's like, I'm gonna slow it down. So see right here. There it is, the vertical resistor. And all the arrows for toolpath outdated. Right click and generate. And then it should do that. Job done. One thing that I might just want to show you more actually is how to make sure that your tool numbering is changed. So you see right here it says T1 and T2. So it knows that it's tool 1 and tool number 2. I had this problem myself going into this because the tool number is what is stored inside the library manager. So you can have two tools. There is tool number 1, but if you go into your and you export your G code and you just tell it to use tool number 1 twice, Mark 3 mill won't stop. Like it thinks that I still have tool number 1 inside my collet, so I'm just gonna keep on working, and then it's just going to plunge right through all the things and try to do that job. You just we have to make sure that the tool numbering is correct. You can use more tools than this, like it will automatically do the calculation for you, but I'll show you how it's done when this finished loading. Otherwise, that is also going to be the last thing that I will show you guys. So if you have like last minute questions, just type it out now so that I actually will be able to see it. Just also because of the delay that there is between me actually saying this and you hearing it. I think maybe I was asking a little bit too much for regenerating. So Yeah, I think now that it's so dead that for just speed's sake, I will force close this and reopen it. It takes a little bit, of course, for Fusion to open, but let's just do that. And so in a minute, it will do that. So I will also just briefly go over as Diesel proposed how to post-process this. It's like any other post-process that you would do, but of course, if you were going to do a webinar about it and someone is going to see this as like one video, we will of course go over how to post-process this. Okay. Computer is getting quite hot now. Feels like it's going to take off in a minute. Okay, so file recovery. Can open that. Your preferences set how often that Fusion should do like a save. So it has this file recovery system. I changed mine to the minimum of 1 minute. So every minute it takes like it saves. It's very rare that I lose files, even though that it crashes. Might have to do like the last minute of work again, and that can of course sometimes be a hassle because how much did you do in the last minute? But yeah, especially now with live streaming, it's tough on my computer. There we go. I'm just going to post-process first job up here that way, and I know it's going to do that just fine. So if I want to post-process a specific job, I can either right-click on it and do post-process. Just like fair warning, some people do this a bit mistaken. If you get to do, if you click on a specific toolpath and you right click and do post process, it's only going to post process that one toolpath. Just to make sure that you click the setup and you should be golden. But sometimes the mistake can happen that you have like one selected. You can actually see that that's upside down. C height. C is wrong. Direction. Oh, it is? No, maybe. Sorry, I was upside down. It's doing it. Oh, it's doing it perfect. So, but of course, it can happen that you have like one selected, and you maybe hit post process here, and that's only going to post process that one tool. Just be aware of that mistake. So click on setup, click post process, choose your post processor. We're going to use Mark 3 mil, and you should make sure that minimize tool changes are turned off. Like it shouldn't do any difference for this kind of tools, but that's just a good thing. And I also have, I think it's important that you have this preload tools turned off as well. I don't think that you have to do stop on tool change in here. No, perfect. Mach 3 will do that if it's it should do that. We hope it's like that. Then just OK, and save it somewhere to your desktop. That's the thing. And the last thing was going to be tool order. So if we are going to make sure that the tool order is correct, oh, not simulate, that's not the thing. Tool library. So I can delete these two tools, I don't need those, and just have these two. So they are number 1 and number 2. So the way that you make sure to renumber them is that you highlight both by holding Shift, and then you click renumber tools, starting from 1, incrementing by 1. So it just tells me that it's going to be, it doesn't going to change anything in here. But when we do start with something, if I just edit this tool under my post processor, it is going to listen to what tool this is. So if I set it to 1 and accept, I should actually turn on manual tool change here. I don't really know if it does a difference, but wow, it is really painful how slow this is. Yeah, just to show you. Now I have two tools. There are both a number 1 tool, and that shouldn't happen. Okay, guys, that's it. Thank you for watching, and have a great afternoon. Bye.